Matthew Edwards has been professor of physics at Alabama A&M University and served as dean of the School of Arts and Sciences from 2007 to 2011. In the past, he's taught at the University of Pittsburgh, University in Arkansas, I think, worked for the Navy, NASA, et cetera, various government positions. And his topic today will be achieving critical thinking and sustained academic success in the physical sciences. So, Professor Edwards.
So, good morning to you. I'm going to give the short version of my presentation. I'm finished already. And that's okay. I'll say, well, so, morning to you again. I've been thinking about teaching young people more than 40 plus years. And so in my regular research in physics, condensed matter physics, and wave propagation theory, I study how people learn and the features that are needed to have critical thinking. And so my last venture here has been not only critical thinking, but the notion of compartmentalization for sustained success. Although there's no definition of success, we all know it though when we see it. So let me get started then with a little bit of stuff here. I'm going to give some, this is abstract. So in academia, the benefits of critical thinking occurs effortlessly for a large segment of students, and this is especially true for those students I teach in the physical science, graduate students and engineering students and physical science majors. And the rewards of critical thinking, however, develop slowly, if at all, for a large segment of students. These students don't often have the skill sets to form cognitive or mental structures and relevant word association. So we believe that the onset of cognitive thinking begins with simple memorization, recording, value, and et cetera, and contrasting situations. And my abstract continues. Now this is what, so I have spent time studying these 5 features. Of course, we all know Bloom's taxonomy, Benjamin Bloom, and then contextualization, learning in order to place whatever is being discussed in the right relationship with other things so it can be better understood. And then Piaget constructivism will cause popping work on the 3 worlds and falsifiability. And falsifiability here is just the idea of checking open theories to whether or not the information is false or whether or not it's true. And Vygotsky now is a Russian psychologist, he's dead now. But his is cognitive development adaptation. So I'll talk about that just a little bit. And then cognitive mental structures that I believe is really the heart of having an in-depth understanding about what you're dealing with. And so I call these structures before utilities. And there are some 5 of them that I've worked with recently. And recently we've added the notion, which remains to be fully validated, that compartmentalization of one's activity along with the above utility allows for sustained success in academia. So now to get on with this, so the title, all this will be given once again, and I'll move forward there. Why do this? To better understand the use of these 5 educational utilities and their relationship with critical thinking. Critical thinking then is to make appropriate judgment, to better understand the role of compartmentalization regarding critical thinking and sustained successes in the physical sciences. So there are three types of students that I deal with on a regular basis. There are always these high achieving students, and yay for them. There is this other group, the average performing students. I have a lot of them as well. I have mostly, though, the underperforming students in my lower level physical science classes, etc. And so my talk is largely directed at how we get this large group of people to, one, appreciate just the importance of learning itself, and then to move from being one of, in this category, to one of these here. I always have then these students here, like my PhD students that I have. They are self-actuated, self-motivated students, so they are just high achievers. But this other group is the focus here. So we all know Bloom's taxonomy, knowledge, comprehension, application, analysis, synthesis, and evaluation. It's not that the student has to know Bloom's taxonomy. You have to be able to do these kinds of things in order to process information, evaluate it, and give it back either written or orally. And then not only then for the students that I deal with, not only is the cognitive domain relevant, but the affective domain is just as important as the cognitive one, because if the kid doesn't know how to receive information, how to respond, evaluating, and organizing and characterization, then all is lost in the first situation. So this is the second part of my 5 utilities, and you can't see much on this diagram, but contextualization. I'll just mention just one word, cell. So cell, then there's cell in solid state physics, there's cell in computer science, there's cell in biological sciences. So which cell are you speaking of, and how to drill down in terms of understanding which one becomes the notion of contextualization in order to understand new concepts. Let me go on from this. So I'll go on. Now, Piaget Constructivism. It turns out for my high-level students, these master's, PhD students, and even the advanced physics majors, this works quite well. The notion that information is received and is processed internally, and you can respond. So Piaget states that children construct knowledge internally through their action with the environment. That is true for the most part, I believe. And these actions, he indicates, can be mental by enlarging and refining existing internal schemas, or be physical by manipulating objects. That's this guy. The individual learner initially by encountering objects and by exploring ideas. And the individual tries, according to Piaget, to assimilate these new information in existing schemas or mental structures. And then, if explored, the ideal object does not fit current schemas, the individual experiences a state of mind of disequilibrium and is therefore inspired to accommodate mentally the new experience. That is great. And with the process of accommodation, new schemas is constructed from which the information can be assimilated. Then the equilibrium of the mind as a required state can be temporarily re-established. More of a state of disequilibrium reoccurs each time the individual encounters experiences that cannot be readily assimilated. Now this is great, as I say, for my high achiever students. What happens to my underachieving students when they encounter something that is challenging, Yes, they a moment, let's see, have this state of disequilibrium, but they give up. It does not happen that it's important enough to push through to understand all of the nuances about what the concept is. So I have students that, yes, they are discombobulated, unclear of what's being discussed, but as opposed to pushing through, I say again, to come back to equilibrium, they give up. And so this does not work for many of my underachieving students. But I found out that this cognitive development adaptation by Vygotsky works quite well. So this person here, Soviet psychologist, he asserts that the notion that learning and physical development are intricately connected and inseparable. So the two can't be separated as the previous slide meant to indicate, that you get developed and then you learn. His argument is that the two are concurrent and inseparable. His theories contradicts Piaget's claim on content acquiring and his universal state, etc., and state need to return to equilibrium. He advanced more emphatically that cognitive development varies across culture, yes, and his position for implementing cognitive development is that of nurturing the student to the point of integrating social cultural development and learning. So a great deal of nurturing has to be an integrated part of underdeveloped students. And this person states it well. So unlike Piaget's stance, which states that natural development occurs first and cognitive learning occurs afterward, Vygotsky has the two aspects intertwined. And so I go on here. Learning is not just a mechanical process, etc. Some researchers have had the misconception that students could be receptacle of knowledge rather than active learning. That is not the case. That you must be an active learner to go in depth. It can be argued that constructivism can provide foundation that guides students the entire learning process of new concepts. Now, Karl Popper, though, the bottom line about him as far as time is concerned is that the two previous theories processes do not embrace wrong assimilation of information. The Empire State Building is in Georgia. Okay, that is wrong. But there is nothing, or calculus is needed to be understood before algebra. That is wrong. So this now gives the credence on how the various theories then can be validated to be true. So Popper then has these three worlds. This is the world of physical state, the world we see, the world we interact in. His world two is the subjective state of interpreting world one. And world three is projected things that humans create and make true. So that's why I have him with his falsifiability. Now, these cognitive mental structures, critical thinking is that mode of thinking about subjects, content, etc., in which the individual improve the quality of his or her thinking by skillful analyzing, asserting, and reconstructing it. And mental cognitive structures are one way of doing that. And so there are three ways we have: comparative thinking structure, symbolic representation structure, and logical reasoning. This symbolic representation is what I focus on mostly in this work. Just an example. In organic chemistry, when I teach this physical science 101, we invariably come to the four chief classes of organic compound in living matter: nucleic acid, protein, lipid, and carbohydrates. And if you remember the very famous city Naples, NaPCl, nucleic acid, protein, lipid, and carbohydrates, you do word association, and immediately you have this other group of ideas and information right before you. So just notion of comparing and contrasting and assimilating keeps you able to move forward with learning. I advocate this all the time with my students at this level, and it seemed to help. One more from this nuclear, from basic organic chemistry. Only word association here. These hydrox, ethanols, aldehydes, carbonyl, carboxyl ester. So HCCE is just an idea that you can remember those various quantities. One other here from basic calculus, all of us know that's involved in the sciences. These four are together, but whenever I'm teaching my E&M class, etc., this minus sign needs to be with the integral of sine theta, d theta is minus cosine theta. If you can remember this one, then the other three follows in a pattern. So you always have them. So I tell my young people, just understand one of these, and then you know that the sign, that the minus sign goes with here, the minus sign. So if the minus sign is there, it is there as well, and the other two are positive. So the idea that patterns, structures allow you to assimilate a great amount of information and keep it at your fingertips. This is another one from quantum mechanics, of course, I teach. These are the basic four equations in quantum mechanics: the Klein-Gordon equation, Dirac equation, Pauli-Schrödinger. This is the most elementary one, but the other three are related if you can know this one. So once again, pattern association and comparison allows you to have a great deal of information. Lastly then, my fifth one is compartmentalization. It is defined formally as a defense mechanism or coping strategy, compartmentalization is a notion of how the mind handles conflicting internal standpoints simultaneously. But in this context, in the way I am articulating it and presenting it, coping strategies are short-term solution. Coping strategies are. So I don't want to go there. I want us now to be successful and to sustain success, I maintain. The active participant must accept the conditions of having several full-time focuses. I do. I have, my life is full with at least 3 full-time agendas all the time. And so how then do I manage, and students are in this way too, and even more confounded with things that they are doing now with all the distraction for learning, which is what this is about. So one has to compartmentalize. Additionally, prioritizing is saying no and focusing on the few things that matter most. You cannot do it all. So you prioritize, you realize what's most important, however you define that, or come to that conclusion for yourself, and you exclude other issues. So you do this, and I'll move on. And so you open a compartment, you focus on that compartment, you make an incremental process, and you close that compartment, and then you can move to the next one. So it's a repetitive cycle then of opening, focusing, closing compartments so that you can spend appropriate time on compartment A, appropriate time on B, C, etc., and then you move on. So saying no to things that do not deserve a compartment. Finally then, the 5 educational utilities considered for critical thinking and effective learning and accelerated learning are these that I have articulated already, and I'm learning more and more about these 5 every day. Cognitive mental structure. Additionally, we have observed that compartmentalization as an effective pattern for sustaining success in the physical sciences where many full-time agendas exist at the same time. I'm biased, obviously, towards physical sciences. I spent my whole life there. But these concepts and ideas translate to other disciplines and multi-disciplines as well. So these features allow for critical thinking and sustained success. While I have no clear definition of what success is, I know it when I see it. This is just some literature cited here. And I thank you for your time.